Okay, so hey guys, um, this will be the last networking IP video I'll be doing. In this, I am hoping to cover the network design and hopefully do two past paper questions, from which one will be from the 2019 A-level paper. So if you don't have the 2019 A-level paper, you can go to itguru.lk. You can get any paper you want there. So you can just click the download link and it will pop up. Okay, so before we get into the 2019 paper, I got a question asking about classless IP addresses. There's no such thing as classless IP address. Okay, so again, the first octet ranges. The first octet ranges are the ones which decide the class of the IP address. Class A is from 1 to 126, class B is from 128 to 191, class C is from 192 to 223. So I told you before about the CIDR notation. So the default subnet masks are 255. For class A it's 255.0.0.0. Network information only on the first octet. For class B IP addresses 255.255.0.0, network information on the first and second octet. In class C it's 255.255.255.0, network information on the first three octets. So according to these, these are the default subnet masks. So if there's an IP address which has not been subjected to subnetting, this will be the default IP address. So if we take it in slash notation, let's just take a class A IP address 10.0.1.0. The slash notation would be 8. But let's say this was subnetted, and let's say you were given an IP address of 10.0.1/9. So by this /9, you can see that this is not the default value of a class A IP address. Also, when this changes to a value, like when there's not a default value, either 8, 16 or 24, it doesn't mean that this IP address does not have a class. The class is only categorized from the first octet. So even though the value is 9 here, even though we need 9 bits to cover the network address, this is still a class A IP address. Okay, it just has been subnetted. I don't think y'all will get subnetted IP addresses, but just keep it in mind. Okay, so again, in class B IP addresses, 168.2.30.40, the default slash notation will be /16, right? So if it was subnetted, the 16 will change. So you might get something like 162.172.30.40/ let's say 18. This is not the default value. So this indicates that the IP address has in fact been subnetted. But still, the IP address is a class B IP address because of its range. Okay, so an IP address of class B, let's take another example. IP address of class B, 72.30.40. okay, this can have been subnetted up to 24. So when you look at the number 24 here, you see it's the default value of class C IP addresses, but this IP address is a class B one. So you can see that the default value of class B IP addresses should be 16, but the value given is 24, which indicates that the IP address has been subnetted. Okay, so lastly, to class C IP addresses, 192.168.40.1, so slash 24. The slash 24 is the default value of class C IP addresses. Now if we were to subnet it, let's say 192.168.40.1 slash 28, if this was given to you, you can see that from the first octet that it's a class C IP address, and from the slash notation that it's not the default value of class C IP addresses, so that in fact this has been subnetted. Okay, so if you were given a question in the MCQ paper asking how many subnets that it has been subnetted to, okay, so they can give you a subnet like this one and ask you how many subnets it has been subnetted to. Okay, what you do then is you first find out which class that IP address belongs to. If you take this IP address, you can see it belongs to class B, and then you take the slash notation. It says slash 18, default should be slash 16. So what you do is you subtract 16 from 18, you get 2, right? So what you do is you put this number as the power of 2 to find out how many networks, how many subnets this has been subnetted to. Remember finding out how many bits you need to take to have this many number of networks. It's the same thing. So a binary value can have either 0 or 1, so that's 2 in one place. Like you can show 2 values using 1 bit, so it's exactly like that. So if you again by for subnetting, if you need 4 networks, what you do is you find the 2 to the power closest power, right, closest and equal or greater power. So from this you can see that you need 2, n will be equal to 2, which means you need 2 bits. So it's exactly the same. So 2 to the power 2 networks in this. So if you were given again 168.172.30.40/24, so again you see, you are given slash 24. This is a class B IP address. The default is slash 16. You subtract 16 by 24 from 24. The remainder is 8. And to get how many networks, what you do is you put the number you got as the power of 2. This is 128. So by taking all 8 bits to the network side, we have subnetted the IP address given has been subnetted to 128 networks. Okay, so let's move on to the 2019 A-level paper. So, the common norm is for the networking question to be the second essay question of part 2. Okay, so first up what we do is we have to read the question. It says the school has acquired the following resources to its administrative, admin, laboratory, lab, and library buildings. It says it shows how many resources each building has. Administration has 5 computers and 1 printer. Lab has 40 computers and 1 printer. A library has 10 computers and 1 printer. And then they have given the requirements which need to be fulfilled. So a computer network has to be created to fulfill the following requirements. Each building needs to have its own local area network in order to share the printer. The above three networks are also to be interconnected so that a school information system which is running on one computer in the admin building and the library information system running on one computer in the library building are accessible from all computers. All computers are to be given efficient internet connectivity as well. For this purpose, the school has subscribed to an internet service provider ISP who is to supply the internet connectivity to the lab building. So that part is really important. Okay, so the ISP is to supply the internet connectivity to the lab building. Okay, that part is really important. The lab building is separated from the other two buildings by approximately 500 meters. That is also important because when designing a network, you have to write what cables that you use as well. Okay, so one computer in the lab building is to be used as a DNS server. The other computer in the lab building is to be used as a proxy server. The entire network is to be protected by a firewall. So those are the requirements. There are 4 requirements. So let's move on to the question. The principal has received 192.248.16.0/24 IP address block for the school. The IP addresses for the computers are to be allocated after making 3 subnets from this address block for 3 buildings. Assuming such subnetting is done, write down the relevant network details, subnet mask, and allocated range for each building using the following table format to present your answer. So, 2019 A-level question. It's going to be the second question. Okay, so the important points are each building has a LAN, a local area network to it. Okay, all buildings should be interconnected. The internet is given through the lab building. Internet has to be protected by a firewall. Also, minor details, 2 computers in lab are DNS and proxy servers. Okay, so the IP address given is 192.248.16.0/24. This is the IP address block given. How many networks we need is 3. Networks needed are 3. One for the admin building, lab building, and library. Okay, so to make 3 networks, we find what closest equal or higher power of 2 there is. So the closest one is 4. So we can use we have to get 2 bits, because 4 is equal to the power 2. We need to take 2 bits from the host information to the network side. So if we were to convert this into binary, it's going to be 1000 dot 248 192 224 plus 16 240, okay, and 16, oops, dot 0 dot 0 0 0 0 0 0. So this is what we get. This is what we get when we convert this into binary. And this is the network ID. So this /24 is also the subnet mask. So subnet will be 24 ones covering 3 octets. Oops, shit. Okay, so it's covering 3 octets. So to make 3 networks, we are going to take 2 bits from the network portion, from the host portion to the network portion. So the new subnet mask will be this should be 0, but we are subnetting and we are taking 2 bits to the network side. Okay, so the new subnet mask in when written in decimal format will be 255.255.255.128 plus 64, 192. So this will be the subnet mask. Okay, so this subnet mask will be the same for all 3 networks, all 3 subnetworks. Okay. Okay, now going on to the first network. First 3 octets are going to be the same in every IP address we make and in every host, every subnetwork. So it's going to be 192.248.16, and the last octet I will convert to binary and do the calculations. Okay, so the first network, it starts with the network bits we took to the host bits we took to the network side as 0 and 0, and I've taught you that the last IP address of this network will be keeping these 2 bits same. Each other 0 converts to 1. Okay, so this is 0 and this is 63. Again, we can find it out by dividing 256 by the number of networks we are breaking it into. So if we take 2 bits, we are breaking it into 4 networks. So 256 divided by 4, each network will have 64 IP addresses. So 0 to 63 has 64 IP addresses. So this will be first subnet, 192.248.16.0 to 192.248.16.63. Okay, and when it becomes 0 1 0 0 0 0 0 0, the next available address, the network portion will change, which will indicate a different network. So that's the start of the second subnet. So 192.248.16 So this will be 64, and keeping this network portion the same, when each and every other bit convert to 1, that will be the end of the second subnet. 127, this will be second subnet, and the third subnet 192.248.16. Now the next combination will be 1 0, and all the other bits become 0. It's 128. That's the start of the third subnet because the network bit changed. And the last IP address of the third subnet would be 192.248.16 10, and all the other stuff will become 1, and that will be 191. Okay, so we have gotten the 3 networks we need. We have gotten 64 IP addresses in each, and if you remember, you can't use the first and last IP address of each subnet because it's network ID and broadcast ID respectively. Network broadcast. So if you were to assign computers, you have to assign it from in the first subnet you have to assign it from 192.248.16.1 to 192.248.16.62, and in the second subnet 192.248.16.65 to 192.248.16.126. In the third subnet 192.248.16.129 to 192.248.16.190. Okay, so this is not the pattern they are asking for. What they are asking to is complete this table. Okay, fill out. Okay, so we got 3 networks. You can assign network subnetwork 1 to admin, subnetwork 2 to lab, subnetwork 3 to library, or you can assign subnetwork 1 to lab since it's going to be having the internet service, and then subnetwork 2 to admin and subnetwork 3 to library. It doesn't matter which order you assign the subnetworks to, but it will matter if they have asked for a specific IP address range for a specific building, but in this case they have not. So let's go with subnetwork 1 to admin, subnetwork 2 to lab, and subnetwork 3 to library. So the network address of subnetwork 1 was the very first address of the given range, 192.148.16.0/26, because we are using 26 ones to cover the network portion, and by /26 you can see that the IP address has been subnetted. The subnet mask, however, will remain the same in all 3 subnetworks. So it's 255, 255, 255, 255, 120, 192. Again 225, 255, 255, 255, 192. The same thing, 255.255.255.192. So the IP address range, in the question they have not specified if they wanted the total range or the valid range. So you can either write the total range and or the valid range, or the total range and the valid range. Let's go with the valid range here. Okay, so both answers are given marks because they have not specified which range they want. So let's go with the valid range. So every time you're writing an IP address, you have to write the slash notation. It is really important, and if you don't write it, you will lose marks. So the first usable IP address is 192.248.16.1/26, and the last IP address will be 192. Last valid IP address will be 192.248.16.62/26, because the last IP address of this this subnet will be 192.248.16.63. Okay, so moving on to the next subnet. Next subnet starts with 192.248.16.64. That's the network address /26. So the IP address, let's take the valid range again in all let's take the valid range in all three subnetworks. 192.248.16.65, because 64 is the network address, /26 to 192.248.16.126, because 127 is the broadcast address of subnetwork 2. 192.248.16.128 will be the network address of subnetwork number 3. The first usable IP address will be 192.248.16.129, and the last usable will be 192.248.16.190. So that's how you fill the table. There is in fact another way to write a range of IP addresses. You can go you can write it as you can write the first IP address range as 192.248.16.x/26, where x is greater than or equal to 1, less than or equal to 62. So it covers the entire range in this. So you can write the second IP address range as well, 192.248.16.y. Since we use x, we have to use another variable here, /26, where y is greater than or equal to 65 and less than or equal to 126. So we can write the third subnet address range as well in the same method. So moving on to the next question, it's give one reason as to why a fully connected all-to-all network topology is not suitable for this computer network. So we have not made videos about the other parts of networking. For now, you all just wanted the IP address part. So one reason as to why a fully connected network topology is not suitable. Why does the lab why does the administrative buildings and library buildings need to be connected through the lab to the internet? Why can't it be given like this? Internet can be given to all three buildings and connect all three networks together. The one problem is we know that in the question it says that the lab building is approximately 500 meters apart. Okay, so that's quite a big geographical distance between two networks. So the making of a single network, all connected network, will be costly due to the geographical locations the buildings are in. That will be one reason. The second reason will be it will be really difficult to configure. So if everything is in one network, everything connected to each other in one network, it will be really difficult to configure stuff. So assigning IP addresses, assigning printers, assigning DNS servers, assigning proxy servers. Okay, so it will be really difficult to configure the network. And then from the question itself we can get the answer of it not being a required thing for the school. So the school has not mentioned of any requirement pertaining the need to have an all connected network. So no such requirement from the school. Okay, so each one of these three answers will be enough for question number B. So moving on to question number C, the lab administrator who is responsible to set up the school and computer network has requested switches and a router. Showing clearly the network connection topology and devices. Draw the network diagram to represent the local arrangement for the school's computer network, and the lab administrator can implement to fulfill that the lab administrator can implement to fulfill the school's requirements. Okay, so when drawing network designs, if there's internet connectivity in question, so how we draw internet is we draw a large cloud like this, we name it internet. Okay, in drawing network, in designing networks, the only thing which can connect to the internet will be a router. So in between the local networks that the school have and the internet, the linking device will be the router, because the router provides public IP addresses from the ISP for the computers inside the local area network which has private IP addresses to browse the internet, because the internet can only be browsed by public IP addresses, not private ones. Okay, so the next requirement was the network must have a firewall. So the firewall is what comes after the router to protect the inside networks from malicious codes and stuff. And then normally comes the DNS servers and the proxy servers, but in this case one of their specifications requirements were that build a computer in the lab building. Two computers in the lab building will be used as a proxy server and a DNS server. So that the proxy server and the DNS server will be inside the subnetwork of the lab building. So, and it also says that the lab building network will be the network which is connected to the internet. So the firewall directly goes to a switch. This switch is the one which is connected in the lab building. Okay, so there will be computers, and one thing you have to specially show that is this and call it a proxy server. You don't have to draw all the computers at once, like all the computers in this, but the special ones, like they say that you need a proxy server and a DNS server in this from this subnetwork which is in the lab. So you must draw those two. You can do either 1 or 2 computers. Okay, so that's done. So this will be the subnetwork that lab is in. The lab will be given. So the lab was given the subnetwork 192.248.16.64. so near the switch we have to write it 192.248.16.64, because that's how they will know uh, what network that this is /26. So what network this is. So the other requirement was to have the admin building and the library building to connect to the internet via the lab building. So you can take 2 lines and then connect it to the switch of library building and the switch of admin building. Again, I forgot that this the lab also has a dedicated printer to it. So printer. Okay. So then again the same thing. The switch in library, you can do 1 or 2 computers. You have to write the IP address. This is the third subnet, I believe, 48.16.128/26. You can separate the networks like this. The first admin will be the first subnetwork we made, 192.248.16.0/26. We have to show the printers because they have told that there will be printers for each network. And then there's the for the library building, they have talked about a library information system. So we have to show that library information system as well. And for the administrative building, student information system. You can show a computer if you want, but it's not needed. Okay, so this is the network diagram. Okay, now what you have to do is you have to specify which type of wires that you are going to use. So since the lab building is 500 meters apart from the library building and the admin building, the most suitable wire to use to connect the library, lab and admin buildings will be the fiber optics cable, because even though it's a little bit costly than the others, the data transfer is really efficient through a distance. You can't use twisted pair because twisted pair is good for maximum 100 meters. So to connect the library and admin buildings to the lab building, what you can use is the fiber optic cable. And to connect the computers and printers and stuff to the switches, you can use twisted pair, TP. You can use TP. You can use TP. You can also specify the wires used in a different a different place than the network right here. So you can write LAN wires as twisted pair, and to connect um, connect admin switch and library switch to lab switch by fiber optic. Okay, so that's part C of the network question. So again, is the internet. Only a router will be able to access the internet. So the firewall of a network comes behind the router towards the local area network. And it is said that the lab system is the system, the lab network will be the network given internet access to, and two computers of the lab network will be converted into a DNS server and a proxy server, and there will be printers for each network. And it is also said that the administration network and the library network will be connected to the internet through the lab network. Okay, so this is the network network design that we've come up with for the relevant question. So the last question is, give one reason to why TCP is preferred over UDP as the transport protocol for the school computer network. So TCP and UDP. UDP is UDP, user datagram protocol. TCP, transmission control protocol. So TCP is the most used protocol to send like sensitive information and to make sure that the correct information is being sent and is being received by the receiver. So what TCP does is it creates a connection with the two with the sender and receiver, and it sends packets one by one to the receiver, and the receiver acknowledges that it got the packets. So there's TCP is really reliable, and there's no less to none packet loss. So what UDP does is sender receiver. What UDP does is it just sprays the information in towards the receiver. So there will be a high packet loss. If you take a live video streaming service, they use UDP. Sometimes the connection gets lost, and you won't be able to watch it. But then again, it will reconnect. So that's the instance when there's packet loss. They don't check whether the receiver gets all the data that they are giving. So the most reliable method is TCP than for UDP. And in this diagram right here, because we are working with student information systems, it's really sensitive, and it's really confidential. So the protocol which should be used is TCP other than UDP. So this was the 2019 A-level question. I know I said we'll do 2 questions, but I'll do it in another video because that way this video will be short shape. So hope you guys understand. Just drop a message in the comments or in the groups if you all have any more stuff to clarify in either drawing networks or the subnetting part that we did. Okay, cheers.